Today we're going to introduce you the solar cells that move when the LED sensors attract the light source. Our motivation was to automate the solar panels so they can follow the sun automatically and take the most solar energy.
Is solar energy important for climate goals? So it's a clean energy and a renewable energy, so it helps to cut the emission quickly and it doesn't harm the environment. So this is a better way to, while making this project was aimed to achieve the optimization and solve the problems, get the most light out of the sun when possible. So we made a project that centers the sun and tracks the sunlight to get more energy.
Two apps for the project, Arduino and Adafruit for coding. The code was writing on computers connected to a board with solar cells and other components.
Project development part was mainly us getting some ideas from the handbooks and writing our ideas on the whiteboard, then combining all the ideas and creating a roadmap. And we distributed the whole group in 4 parts: ESP32, Arduino, video, and presentation. After we finished the project, we adjusted some parameters like rotation speed and those type of things. And after that, the project was finished.
So now I'm going to explain how the project works a little bit sharper. So here, you can see it here above, are the 4 LDRs. They sense light and the resistance changes, it gets less when there's more light on it. So we split them up in 4 parts and the system calculates the average between the top ones, left ones, right ones, and when it sees that the top ones receive more light than the bottom ones, then the panel changes with the servo motors. These are here in the white part, and then the solar panel changes from its angle. Here you can see it, so this one changes to the most sun, so this receives the most energy. And afterwards you can see it in the screen on Adafruit with the sensors. Here you see a little peak, that was when we had the light on, the big light, because that was more energy, so you can see it has worked.
We had to use a large industrial lamp because the phone flashing were unreliable. The lamp heated up quickly, so testing time was limited. Room LEDs had to be turned off to prevent interference with the light sensors.
Yes, we only had one, and that is to improve the cable management. The conclusion, together we worked as a team where we used English to communicate and everyone helped with their part of the project. All team members learned something new from coding to present on their own level.
Thank you to everyone who supported or contributed to this project. We'd now be happy to answer any questions you have.
Combining these 2 guides are very efficient farm bot, which uses the sensor to measure the amount of water present in the soil to water the plants. In this way, it uses less water than watering plants normally. Background: we choose this project because it seems useful for managing water consumption and ensuring a constant water supply for plants.
As we said before, the project aims to solve the problems of water supply to plants in order to ensure automatic growth. Thanks to this project, we can hope that the plants have constant and controlled growth while also managing the water more efficiently.
So methodology for the approach for this project, we use mostly programming. We tried several methods, but we faced a lot of problems. So mainly we just tried again and again, and it somehow started working, thanks to them. For this project, we use different electronic components as well as Arduino, EDE, a laptop for moving the robots, and an ESP32 system for measuring the humidity of the soil.
The project development phases. So at first we split the group into 2 smaller groups. One group had to make part 1, so they had to move the robot with the Arduino, and the other group had to make part 2 and part 3. Part 2 was about creating an online dashboard to show the humidity live. And part 3 was about connecting the ESP32 to the online dashboard. So the implementation. Programming the Arduino has brought a major problem. At first, it did not work properly, and after that, we got a new one. But this Arduino had problems with getting the right information, so we had to get another one, and it finally worked. In order to test the effectiveness of the components, we carried on several tests for the moment, and we used the Adafruit software to retrieve the data from the sensor in order to know if it was effective.
We had some good results, like I can see in this image, but in the end of the final project, we have a small problem in this picture. Now we have a small big problem.
So for integration, once the project was working, we were able to see that the sensor allowed us to have the water level present in the soil, and that its use was a good idea because it allowed us to have a good data to know. And the limitations were the main challenges we encountered were that Arduino didn't work well at first, and we couldn't control the stepper motors. So we had to solve a series of problems to get the project working. Writing the code was also complicated. The stepper motors were not working.
First, the issues we encountered were mainly because of the messy cabling and wiring management. So I think it's handy to organize everything and label it nicely so you can have much more of an organized way of working. And next to that, also in the code, a few things went wrong. Using a library, for instance, for the stepper motor would have been a good way to prevent any issues. And then, of course, after the project itself finishes, it also has some future directions with new applications. So scale the project up, maybe add some cameras and use AI monitoring to really see what the plants are, how the plants do with growing, and if they get enough water.
We learn how to manipulate Arduino components for movement and ESP32 for measurements, as well as how to work as a team to be able to successfully complete this project. The main takeaways are that without teamwork and the division of labor, we cannot move forward with a project like this, so we work together to develop this approach.
Alright, so that's it. We also want to thank the teachers for making this project possible and making such a great thing to do for us. And if there are any questions, we would like to answer them right now.
Questions?
Well, our project is a small wind turbine that generates and measures energy. Our motivation for choosing this project was the initiative to making green energy and protecting the environment.
Our objectives and goals were: the project aims to work with a wind turbine by force from the wind and making it rotate. Our objectives and goals were: building a small wind turbine that produces electricity and monitoring the data. The turbine turns toward the wind and makes energy more efficient, and we can monitor the outcome.
For coding the project, we use Arduino IDE, and for making the dashboard, we use Adafruit. Tools we use were jumpers, jump wires, breadboard, power supply, DC motor, coaches drill, Allen key, wind turbine kit, resistors for the wind turbine output, and technologies we used are Arduino Uno, SPN32 Vroom, wind direction sensor AS5600, motor driver H-bridge, voltage and current sensor ENA226, and Wi-Fi via SPN32.
Project development phase. First step, programming Arduino to make the turbine turn with the wind direction. Second step, create an online dashboard on Adafruit EO. Third step, ESP32 data monitoring. And fourth step, reflections and extensions.
These are the results that we got. Here is the data monitoring in Adafruit. Here are the components.
And here's the turbine without the wings and with the wings.
So we didn't have many problems, but we did have one with the sensor and the voltage because it was wired wrong. But we could quickly fix that. And also some people in our group didn't know how to program, including me. So we had to do other things like the presentation and the video. So we all worked and did something. And the turbine, in the beginning it was unaligned and we didn't have another sensor.
I want to talk about the future improvements and maybe we can use some shields or boxes for protect the electronics, because you know when the sun or the dust can damage the electronics so quickly, and maybe we can add some shutdown feature for our safety.
Our point was making energy more efficiently and safety planning. We learned to work as a team and know each other.
We thank the teacher team for supporting this project, and I thank personally teacher Fritzer for helping me learning Arduino for the first time of my life.
Hey, we are the fourth group. Our project was named Greenhouse Monitor Prototype with home assistant and ISP home devices. Okay, the project overview. We did the greenhouse monitor prototype that measures moisture, temperature, and light, and can automatically control these conditions through a home assistant.
Yeah, hello everyone again. Right now, let me explain a little bit that how does things work together. At first, we have 4 sensors, 4 ESPs, and 1 Raspberry Pi. And then we made them all work together via using ESP Home, and then we integrate the ESP Home to Home Assistant that we can see the values of light or values of temperature, or just we can control the water.
By using this project, we significantly reduce the amount of electricity used at home, and we also live an easier life because we can control our home remotely. Electricity waste in homes has reached a very large size, and we need to reduce this amount for a healthier environment.
Our aim was to produce green energy and automatically operating greenhouse. The goal was to improve plant growth through automation and real-time data.
So the materials we used, we first needed a secure Wi-Fi network, so we could use our Raspberry Pi. That's a small, strong mini computer. Then our sensors, a DHT sensor that measures the temperature and humidity in a room. An LDR is a light sensor, it reacts to light. If there is more light, it will give a higher voltage. And a soil moisture sensor, it just goes into the soil and it measures how much water it is, and if it needs water or not. Therefore we have a water valve, a servo motor to open a roof if there is too little light measured by LDR, and we use ESP's 8266 to code everything.
And like Kaan said earlier, we have 3 main components to make our project possible. At first we have Home Assistant. It's like an open source free software that we run on our Raspberry Pi to connect all the sensors and devices in one place, in one central place, to read them, to connect them, to see the values they give, and also like a servo to monitor it and to change the values. We use ESP Home. It's like an add-on for Home Assistant, and it makes it possible to use the ESP to little devices and to connect them through Wi-Fi to a Raspberry Pi, which is running Home Assistant. And we have multiple sensors like the DHT sensor, the light sensor, the moisture sensor, but we also have actuators which we can change to Home Assistant, like the servo and the valve. We can turn the valve on and off to let the water go through or to stop the water. And servo we can change so the roof goes open and close.
The biggest problem we had was we couldn't directly connect the ESPs to ESP Home, so we decided to directly put the code in it using manually by using the ESP Flasher, which is a free software we found online.
We also want to thank our teacher Rad for helping us through everything.
Thank you for listening.
I want to thank you all the groups, for the great work you have done the last days. And I think it's time to have a look in at your projects. So I would like to ask you to have 2 people or 3 people in your own project, but also walking around to see the other results, of course. So we will visit with the teachers your projects, and we'll be there in a few minutes.
Hello everyone, and there is our IoT home project. We have 4 ESPs and 1 Raspberry Pi. There's Aldear sensor, there's DHT inside of the box, there's moisture sensor, there's servo inside of the box again. At first, let me explain how the Aldear one working, and then my friends continue. As you can see, there's a little thing in here. This is our Aldear sensor that it shows us volume of light. And when I put my finger on here, as you can see, our home is going to open. And when there's enough light, it's closed again. So Seth, can you explain what moisture sensor is doing?
Like for the dirt, if you have a little garden, you have a moisture sensor. It detects how much water is in the dirt, and if there's above 50% something, the valve opens, so water comes in. If there's too much water in the dirt, the valve will close and no water will come in. That's the basics of the moisture sensor. Yes, you can read the moisture sensor on the screen. It's now at 46.8%. So that's the level of the water that's inside the dirt right now. And take the water. Yeah, nice and easy.
No problemo.
It will come out and you can see the moisture level go up. You have to wait a little. 47. Yes. And now as you can see, the switch is closed, so no water is coming out anymore.
The DHT sensor in here. This is temperature sensor. If just I will. So the temperature is going up.
Thank you for
Thank you for watching.
Hello everyone, this is Farmboat. It has some stepper motors and a pump, and these are the end stops, so it moves, and when it hits there, it stops, and when it completely stops to a coordinate, it lowers the moisture sensor by the servo motor, and it reads the data, and the data is if it's under a value, it pumps water from there, and then it leaves and goes to a different location to measure the data and do the same things. And in here we have a moisture level of this. It reads data and sends to the web from the ESP32.
We worked very hard at this project. We had to code a lot, so it was very difficult for us to do it. Yes.
And then you wake up.
Bye. Bye.
Hello everyone, we are in our smart solar panel station right now. Our solar panel consists of 2 motors and 1 LDR sensor. What this solar panel does is it tracks the lights, and based on that it moves, but now we need to settle it. Restart. Okay, like it goes to the flashlight. Because the phone's flashlight is so low, it can't decide where to go, but when we open this big light up, we can move towards that side. We can move towards that based on the this, it can move more efficiently. Other than the usual solar panel we have around, it's more efficient and more optimal because of its design. That's all. We use ESP32 and Arduino microcontroller while making this project. And also we have a dashboard here, but it timed out because of some issues in our code.
With the programming with the Arduino for the solar panels, we had sometimes a problem because we used the same script, but it didn't work. Here you can see all the loose cables, and yeah, you need to find which one is loose so when it worked again. So sometimes it didn't work, but most of the time it worked. So now it works.
Okay, so while programming we ran into some problems. We noticed that sometimes the server wasn't turning well, and we found out that those problems were partially caused by the cable management, because loose cables could get stuck in the gears, so the servos couldn't move correctly. And we had to work really hard to find some solutions to program it so it did work.
Give it smart!
Give it smart!
Hido!
Hello, we are presenting the wind turbine. Here we have the components. This is the Arduino. We use this to make the turbine spins. And this is the ESP32 that makes the data monitoring. If you do this, it spins, and it's for the direction of the wind, so we can capture all the wind and we get more energy. This code is for the data monitoring, and here's the site for monitoring the data. We can get the voltage, the power, and the current. Thank you for everything.
Thank you for everything. Bye bye.
Maybe 25 minutes. And I would like to finish this event, this LTPA. I would like to start with the French team. Jason. Smaller, shorter title, but this time it's a Green Industry Vocational Education Training for Sustainable Manufacturing with IoT. Next time it will be Given Smart only. Yeah. Okay, Baptiste. Thank you. From Provinia. Liga. Anna. Spain, Gran Canaria. Orlando. Hernandez Belia. Monica. Turkey.
Woohoo!
Thank you. And the last
Special one.
Hakan.
Hakan. Portugal.
Francesca. Angela. Diana.
One is called the other station.
Jose.
It's called José Lemos.
Luis. That's the group I'm also proud of. Not only the teachers but also the students of the Netherlands. They are here for a full week. Normally it's not easy to get here for 1 week. But I want to thank also the Dutch colleagues and students for being here and support this project. I love to see you in the next project of Sommel. Ruben! Hernandez. Mr. Pim Henderson. No, I give you the number of notes. Fast. Last one, mensen. Zand. Did I miss someone?
Yes.
Oh. This week to see you all here in the Netherlands.
I went at the end of this journey to years different countries. I want to say thanks to you, the coordinator, all the coordinators, all the teachers, all the students. During 2 years, I have been these special moments, many special moments with us. We are now 6 countries. I think that
6, 7.
we are now 6 countries.
Thank you also.
Come on! Woohoo! Thank you, bye. See you in next project. See you. Thank you very much for everything. Bye bye. Thank you for everything.
J'ai espoir de refaire un projet avec toi.
Hello. Hello on this meeting. I'm sorry we have to go, but next time we'll back.
Thank you so much for this great experience. I'm very glad to be here. I hope to share an experience with all countries that are making part of this project.
I'm happy to see all the people here happy, and the project was 2 years, but it was a great project, I think. Together with the partners, we have great partners to work with, and the students, you see, they love each other, to working with each other. That's the thing we need. Bye bye.